log to any base of 1 is 0, because base b to the power 0 is 1, right? B to the 0's power is 1. Okay? We have learned that before. I just want to make sure, don't forget about it. How about log to the base b of b? What is that? B to what power is b? 1. Of course, right? So log phi of phi is what? 1. Log 131 of 131 is what? 1, right? Okay? So far, so good? Just to, make sure that you don't forget about those basic things. And we have learned in the past, when we talk about inverse functions, f composed with f inverse of x is what? X. F inverse composed with f of x is what? X, right? Remember we talked about this inverse train from Los Angeles to San Diego, and then take the inverse train from San Diego to Los Angeles, right? Okay. So because of this, if you are going to have a as a base, okay, so this is exponential function. So let's look at exponent. But in the exponent is log with the base a of x. Then it should be what? It should be x. Okay? Or you have log with the base b. Okay? And the argument is base b to the power x. Then the answer should be x as well. Right? That means you take the exponential function with the base b, b to the power x, and then immediately you take the inverse function, which is a log with the base b, you will get back to wherever you start. Yeah? Okay. So remember that we have one example before. 7 to the power log with the base 7, 49. What is the answer? 49. Remember that problem? Yeah? You can actually evaluate what is a log with the base 7 of 49. That is 2. And 7 to the power 2, it is 49, right? And if I have 13 to the power log, also with the base 13, 792, then what is the answer? 792, right? Because it's inverse property of logarithm. And if I have log to the base 11, and then of 11 to the power, what is the number you like? Give me a number. More interesting number? 13. Okay. Actually, it's just the input that I want you to give me, because this base is 11 for the exponential, and that is the same as the logarithm with the base also 11. So the output should be still 13, right? That is the inverse property of logarithm. Is that okay so far? Okay, one more. 23 to the power log, also 23, and then I have square root of 5, and the answer should be square root of 5, right? So people ask you, what is the property? If I want you to write the reason behind it, you should say what? Inverse property of logarithm. Okay? Is that okay? If I have log to the base square root of 3 of square root of 3 to the power 71, the answer should be 71. What is the property I use? The inverse property of what? Of logarithm. Is that clear now? So the whole idea based on these two properties that we learned in the previous unit. Is that right? Okay. All right. Now let's look at the second property. What is the second property? The second property is the product rule. The product rules of logarithms. Let me come back to this previous property just to remind you the graph. I think that helps you knowing these two fundamental property. Okay, remember how we graph the log function? Okay, if I'm going to do base 2, y equals to log to the base 2 of x. When x equal to 1, log to the base 2 of 1 is what? 0, right? What is log to the base 2, 1? 0. What is a log to the base 2 of 2? It will be 1, right? What is log to the base 2 of 4? 2. Great job. What is log to the base 2 of 8? It should be 3. Okay. The reason why I'm doing this because I know some of you not still learning. Okay. Log to the base 2 of 1 is 0. Log to the base 2 of 2 is 1. Log to the base 2 of 4 is 2. Log to the base 2 of 8 is 3, right? Because what? 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8, yeah? And then how about log to the base 2 of 1/2 is what? Negative 1, yeah? 1/2 is here. This is the graph of log. You see that? Is that okay? All right. Now let's continue for the product rule of logarithm. We are talking about product. So m times n is a product. Is that right? Okay. And I'm going to take the log of this product. The base could be any base b. Okay? What would be the result for the log of a product? The log of a product is the sum of logs, right? So that equals to log to the base b m plus log to the base b of n. Why? Why? Well, yes, the base must be the same, but why? There's no explanation on the book. Most of this level's book don't say why. Wow, awesome. How do you prove it? We need a proof. Wow, we have a mathematician here. Great job. What did he just said? Remember, yeah, you actually have very good understanding. Remember the log give you what? Exponent. Remember that? Log, let's come back here. Log to the base 2 of 3 that give us the exponent 3. Log to the base 2 of 8 give us the exponent 3, right? Yes? 2 to the power 3 is 8. Do you see that? Yes or no? Yes. Wonderful. Now, this is a product. So we are going to find the exponent. If you multiply two things together, what will be the exponent of a product? Well, when you multiply things with the same base, the exponent will be what? Add up, right? Remember? That is a reason. But how do we prove it? No proof on the book. I will try to, make a very simple, statement so that you understand, okay? Can I let this to be called by some symbol? How about let me call this X? Is that okay? Let me call this Y. Is that okay? All right? So I let X to be log to the base B of M, and let Y to be log the base B of N. I just give a name for these two terms. Is that okay? So far, so good? I didn't do anything. I just say, call this guy X, call that guy Y. All right? What does it mean? That means, let's try to write this in exponential form. What is the exponential form for this? What is the base here? B. What is the power? X. So it means B to the power X equals to M. Is that right? Okay, now next. Everybody say out loud. That was B to the power what? Equals to what? You are awesome. You just had a test, right? Okay, from logarithmic expression to exponential. It's just equivalent. Am I correct? Great job. What am I doing? I am multiplying them, right? So let's multiply M and N. M times N. So what is M times N? Say out loud. It will be B to the power X plus B to the power Y. Is that right? Okay. And I want to take what? I want to take, oh, I'm so sorry. I'm saying that multiplying, right? I'm multiplying M and N. Is that right? Okay. So can you tell me how do you multiply B to the power X with B to the power Y? They have the same base, right? When you multiply, you get what? B to the power X plus Y. Are you with me? Yeah? That is the exponent rule, right? Okay? So far, so good? So far, so good? Okay. Now, I would like to take what? Log. Remember, our property is to figure out what is the log of this product. So let me take log on both sides. See? The left side equal to the right side. So I'm going to take log on both sides. Take log on both sides. Okay? So I'm going to take log, okay, with the power B. On the left side, it should be log to the power B of the right side. Does it make sense? Okay, the left side is M times N. The right side is B to the power X plus Y. Got you? Okay. Okay. Now, my friend, you are my dear friends. Okay. Let's look at this. Wow. What is the base? B. Thank you. What is the base altogether? B. So you are taking the exponential function, right, with the base B. And after that, you are taking the log with what base? What is the base here? B. So you take exponential function with the base B. And then you take the log function, which is the inverse, with the base B. So by the inverse property of logarithm, the first property that we learned, you should get what back? Oh, you are so good, right? You get whatever, because remember here, if you are going to have 12 and then log with the same base 12, square root of 2, the answer is what? Square root of 2, right? Because they have the same base. Log and exponential are inverses of each other, right? So now here, this is a base b, and this is a base b. This is exponential, and that is log. They are inverse of each other, right? So you get what? X plus y. Can anyone come up here for extra point explaining this? Come. Okay, come here. Just to explain. Explain this. How do we do it? What is the function here? Exponential, right? And then you take its inverse, which is log with the same base. So you get the identity. Is that okay? Does it make sense? Yeah. Okay. Now you tell me, what is x? X is what? We say here, x is what? Log to the base b of m. What is y? It's log to the base b of n. Awesome. We prove it. Log to the base b of product equals the sum of product. Sum of logs, right? Is that okay? So we often say log of a product is the sum of logs. So people say log of a product is the sum of logs. This is how people say it and remember it. So far, so good? And I can see some examples over there, and I'll try to list them down here. Okay? Can I have all of you look at the board there? Okay? Can you see clearly? There are some examples that are provided by the group sitting there. Okay? Can you see? Yeah? Let me come back here. Maybe it's better that we put on the paper. I just choose some for practice. Example 1. Log to the base 2 of 12. If I give you this, then you would try to factor 12. You say, hey, what is 12? 12 is what? 3 times 2 squared. Oh, let me say, don't do that fast. We will just say 3 times 4. Is that okay? Log to the base 2 of 12 is log 2 to the base 2, 3 times 4. So 3 times 4 is a product of 3 and 4. Is that okay? You want to have different example? Yeah, we can do that later. Okay. Log to the base 2, 3 times 4. It will become what? Log to the base 2, 3 plus log to the base 2, 4. Yeah? Is that okay? But what is log to the base 2 of 4? 2. So this will become what? Log to the base 2 of 3 plus 2. Is that okay? Okay. Example 2. log to the base, say, 3 of x plus 1 times x plus 2. Okay? Now you see, this is a product of two factors. Oh, then you immediately see we should use the product rule, right? This is a log of a product. Log of a product. So it will become what? The sum of logs. So any volunteer? It will become what? Log to the base 3 of x plus 1 plus altogether log to the base 3 of x plus 2. I have a student, very good. When he saw this problem, he said, oh, let me distribute. X squared plus x plus 2x plus 2. So he got this. And then he gets stuck. He says, oh, I never learned log of a sum. Well, he combined the like terms and it becomes this. Can you simplify from here? Can you? Okay, then you say, you know what? I'm going to force it. Just make it this. He just invented his own rule. You say, wow, I will try, see whether Dr. Chen will give me correct. And you know what happened? He got wrong. Of course. There's no such kind of sum law, okay, or rule, some rule for the product. No way, Jose, okay? You will not like to have log of a sum because there's no way for you to find the way to simplify it. You want to have a log of product. See what you have? You have a product, okay? You have a product. And you don't want to distribute it. You want to keep it as a product, and then it will become a sum. Is that okay? Okay. Let's do the next example. Log to the base 3 square root of 11 times square root of 5. All right. What is that? Is that a product? Yes. So you are happy. You say, well, it becomes what? Log to the base 3 of square root of 11 plus log to the base 3 of square root of 5. Okay? Can I continue the simplification? Yes, we will come back later. Okay? We will come back later. We'll keep it for now, and we'll come back later. Okay? So far, so good? All right. Now, let's look at the next rule, which is the quotient rule. The quotient rule of logarithm. The quotient rules of logarithm. Okay? If we have a quotient, and I want to take the log to the base b, what would I get? We would like to have comparison with the log of a product. Okay? If you have a product, it will become the sum, right? We can prove, just like what we proved for the product, you're going to see the result is going to be similar. Instead of a sum, it will become what? A difference. Okay? So it becomes the difference of the log. So it will become log to the base b of m minus log to the base b of n. Is that okay? So far, so good? Okay, now let's have some example. Log to the base b x y over Z W. Okay. I give you 1 minute to do this. Everybody do it. This is a law of a quotient. Okay? And you will have a quiz after this. What would you have? Okay. You know what? I have a suggestion. You will have to write it a little bit larger because this is not in the power. This is actually here. Can I write it?
Yeah, sure. Okay, I see.
Okay. But you can continue. All right. I saw some of you already done. Let's do together. It will become what? Log to the base b of xy. Remember, put the parentheses, okay, because they're all together. And then minus log to the base b of zw, okay? Some of you are very good. I saw that you observed this is a product. This is a product. So can I use the product rule? Yeah. Oh, yes. Okay, continue. It will become log to the base b of what? X, and then plus log to the base b of what? Y, and then minus log to the base b of z. Okay, I heard you say log plus log to the base b of w. How many of you got this right? How many of you got this? Okay. How many of you not getting this? Okay. Okay. Is this right? Is this right? Oh, yes. This is the common mistake. Sorry. So what's wrong? You say, Dr. Chen, didn't you just say a product, it will be a sum? Yes, I did say that. But you are all to be careful that this is a subtraction. You are subtracting the whole thing, so you need to put what? A parentheses. So if you do that, then you will have actually subtracting log to the base b of z, and also subtracting here, it should be minus log to the base b of w. And this is the common mistakes that we see every semester, okay? It's not this chapter. It is your pre-algebra. It is how you subtract a bunch of terms. You have to subtract each one. So how to avoid this mistake? How to avoid this kind of mistake? Okay? We try to write a quotient as a product. Because people are good in doing addition. People sometimes very careless in doing subtraction. So let's do the same problem one more time. And you will know what do I mean by that. Okay? So this is a very simple example. So I would like to write log to the base b of xy over zw. I will get log to the base b. I try to write this as a product. This is a quotient. How can I write this as a product? You will have x, y times what? Z to the power -1 times w to the power -1. Is that okay? So now this is a product. Am I correct? Is this a product? Yes. So now what will we have? Because this is a product, it will become a sum. Am I correct? Okay? It will become a sum. It will become a sum. And now I need to use a power rule that we are going to cover next. Let's write it down first. It will become log to the power b of x plus log to the power b of y plus log to the power b of z to the power -1 plus log to the power b of w to the power -1. So now it's a sum of 4 terms. Is that okay? All right. So far, so good? No.
I don't understand why you put -1.
Oh. Why I put -1 here is because it's in the denominator. What is 1 over z? Why? 1 over z is z to the power negative 1. Is that correct? Okay? So things in the denominator, if you write as a product, you will have negative exponent. Is everyone with me?
Wait, so you can't do it the first way?
No, you can do it the first way. Have with care, with carefulness.
We can't leave it as x, y, minus
No, this is not done yet. You have to go to the very end. Okay? All right. Now with the power rule, which we are going to cover, so let me tentatively leave this page. Can I have all of you leave one more line here? Okay? We are going to use the next power rule. Power rule. It doesn't matter. It doesn't matter. Okay? Can I have all of you leave one line in your notes? Okay, we will come back. Okay? Which is the power rule we're going to use. Power rule of log. Okay, now let's look at the next property, the power rule. Power rule of logarithms. Okay? What is the power rule of logarithms? If you have log, okay, to the base a of m to the power r, that will equal to, look, what do you mean by this power r or exponent r? That means you multiply m how many times? R times, right? So if you multiply m r times, it's a product, isn't it? Yes? It's a product. Oh, what did we just learn as a product rule? It will become a sum, right? It will become a sum. So you end up with r of so many log to the base a of m. Example. It will be easy for you to see example. Log a to the log to the base a of m to the power 5. What do you mean by that? That means what? Log to the base a m times m times m. How many times? 5 times, right? And using the product rule tells us what? It will become the sum, right? Are you with me? Yes or no? Yes. Some of you not quite sure. I will do it slowly, okay? You will become m times m to the power 4. Agree with me? So let me do just two factors. Then you will know it will become what? Log to the base a of m plus log to the base a of m to the power 4. Happy? Yeah? Just two terms. Yeah?
Why is the product rule the equal sign?
Oh no, this equal to this. I just write down what is a property that we use. It's a product rule. I just write down the property that we make use of. Okay? Now you can do continuously for this m to the power 4. It will become log to the power a of m plus log to the power a. Now this will become what? M times m to the power 3, right? Is that right? So you will become log to the base a of m plus log to the base a of m cubed. Do you see that? Yes? Yeah.
Isn't it just easier to put the 5 in front of the log AM?
Oh, of course, because I need to explain to everybody. So I do it this way. Yeah, eventually you will see that because people say why, right? Okay? Yes. You're ahead of all of us. Great. Okay? Now you can do this. Okay? It will become log to the base a of m plus log to the base a of m squared. Obviously, you are going to have log to the base a of m plus log to the base a of m. So How many of them? 5 of them, right? I'm doing this for all of you to see, yes, you can do it slowly by using these product rules, and you are going to see there are 5 of log to the base 8 of m. So people say, yes, it is this power rule, nothing but repeatedly using this product rule. So the rule says, if you have power 5, this power 5 can come out as the coefficient and multiply f front here. Okay, do you see that? So wonderful. This is a very useful rule. Now, let's look at example. Example 2. Log to the base 7 x over y square z. Okay? Let's do together. Okay, can I? Okay, let me put w here. Let me put w cubed here. Okay, can I have all of you make sure that you have the same problem? Log to the base 7 of x w cubed over y squared z. So what should we have? Can we say out loud? It will become log to the base 7 of what? X w cubed minus log to the base 7 y squared z. Is that all for you? Yes. Equals what? Now this is a product, so it become what? Log to the base 7 x, right? Plus log to the base 7 w cubed, yes? Now here, what is that? Minus log to the base 7 y squared, and then? Thank you! Minus log to the base 7, what? Z. Yeah? All right. Am I done? Not yet, right? You still see power. So we need to use the power rule, right? Using the power rule, the exponent will become the coefficient. So you get what? Log to the base 7 x, and then plus 3 log to the base 7 w, and then minus 2 log to the base 7 y, minus log to the base 7 z. Is that okay? Make sure, be careful, okay? Be careful. You have to subtract the whole term here, so you need to distribute the negative term, negative sign to each term. Now let's come back to the previous one. Okay? Remember, we tried to write the quotient as a product. Okay? So what happened here? What is the exponent here? -1. So by using the power rule, it will become your coefficient, right? So can we finish this one? It will become what? Log to the base b x plus log to the base b y, and then minus log to the base b z minus log to the base b w. Is that okay? Okay? So now this is correct. You can use either way. Okay? It doesn't matter which way you use. In the past, many of my students said if they change the quotient to product, helps them to avoid that distributive property mistake. Okay? But if you are good in doing that distribution, then you can go with either way. Okay? Great. So we have the last one, which is the change base formula in this section 8.4. Okay? Sorry? Tuesday, we do not have school. Right. Let me quickly show you the change base formula. Okay, the change base formula. What is the change base formula? Change of base formula. It basically say log to the base a of m is simply just log m over log a with any base b. Okay? Of course, we know a cannot be equal to 0 and b cannot equal to 0. Okay? And m is positive numbers. This is a change-based formula. So what do we use this? In calculator, we only have two bases. One is base 10, one is base e. And we write this ln for log to the base e. E is a number about 2.71. It's just like pi is about 3.14. ln is the log with the base e. Okay? Now, example is very clear. If somebody asks you to write what is log to the base 2 of 5, you say, give me an approximation. Then you take your calculator, you say, no problem. We learn in Dr. Chan's class. We can write this as log 5 over log 2. What is the base right now if I don't write it? It means what? Base what? 10. If I just write log, that means log with the base 10. Is that clear? Okay? So you all have your calculator. You can, punch into your calculator and find out what is log 5, what is log 2. You will find it. And you are going to see it is the same as you use ln function. ln function is the log with the base e. And you're going to see, yes, if you use this quotient, you will find the same answer. That's how you calculate log with the basis that is different from 10 or e. Is that okay? This is the base what? 2. Do you have base 2 in your calculator? No. On your calculator, you only have what? Base 10 and base e. On all calculator, we only have base 10 and base e. So you need this formula to help you find out the value that has base different from 10 or e.
Can't we just plug it in though? Log 2 log base 2.
Oh, your calculator can take that? Yeah. Are you sure? Wow. Awesome. You have a modern calculator. Okay, most of the calculator only have those two bases. Okay? So we are done with the 8.4. Yes. Yes. Okay? So you are going to MML homework, okay? And you are going to see the textbook homework. And you will have pre-reading, which will be posted on Canvas. Okay? Tuesday, no class. Tuesday, no class. Okay? But when you come back on Wednesday, you are going to have a big quiz on this 8.4. 8.4 is very, very important. A very big quiz on 8.4 on Wednesday. Thank you for your attention.
Can you post it tonight as soon as possible?
Yeah. Okay. You mean tonight?
Or like Apple?
Now? I will. Well, it has to be this afternoon. Okay, this afternoon. Yeah.